Okay, so when we left off last talk, we had a class called Circle. That's a few classes back. Circle, and then we inherited from that a more specific type of circle we call the graphic circle. Okay. So then it turns out we could have other objects that are not circles, but other objects. Similar setup, we could have a square, and therefore a graphic square, which would have the fill and the color inside the square. And same thing for triangle. Right, same idea. We have different types of objects, but these objects all kind of have something in common. They're not completely random objects. They're somehow connected to each other. And so what we can do, the first topic we'll talk about is abstract classes. So what we can do is we can decide, this would now be, this is a constraint we're putting on ourselves. So you might think, why would we put this constraint on ourselves? But it's a design issue. What we can do is we can create another class called shape, which is a vague class. And we can have all of our different types of shapes inherit from shape. Now you might think, why put this restriction on ourselves? Now we have to look at what's in shape, and what's in shape has, we're going to automatically pick up, and maybe the square doesn't want some stuff that's up here. So what we'll define in shape is something that is true for everything that we consider a shape. So we might go and write the class for shape as something like this. Public shape, public class, and I'm intentionally leaving some room here. And I'm intentionally leaving some room here because I'm going to write a word there in a second. But we might decide that we want every one of our shapes to have two functions in them. One that calculates the area of the shape, and one that calculates the perimeter of the shape. So we could have let's spell perimeter.
P-E-R-I.
P-E-R?
Yeah. I-N-T-E-R.
Okay. Okay. What's that?
I thought you said parameter, I was like P-E-R, what?
Okay. So anyway, let's say we wanted to have all our shapes, for design reasons, they all have something in common. They all have an area, and they all have a perimeter. What we've done right now, and I've intentionally left space here, here, and here, because I want to put a word in there in a second, but I want to describe what the word means. So what we're doing is we're saying this class shape is going to be something that these are all going to have attributes in common about. We've defined two methods, but the methods have no body. Normally we're used to seeing, when you define a method, so this means the method's going to return a double, it takes in no parameters, but then you're expecting to see open paren and a bunch of code and closed paren for the method. We're not defining any method, we're not defining any body. All we're really declaring is that this method exists. But what if, okay, so now if somebody created a circle, since circle inherits these two methods, we can call the area function. The problem is it doesn't do anything. So if we said, you know, if we had something like, if we said C equals new circle. New circle. If we created a new circle and then said C, you know, and then said x equals C dot area, we could take the C object and call its area function. Whatever the result is will get returned to x. This is assuming x is declared as a double. But it doesn't do anything yet. All we're doing is saying the method is there. We're not saying what the method does. So this sounds strange. And what would you think would happen if you called an area function, a function that doesn't know what to do? At first, right now it seems like, why are we doing this? We're like adding a burden onto ourselves. But what do you think would happen if you called a method that has no body to it? If you were designing the language, would you let this compile, giving a method that has no body? Someone may call it and you don't know what to do, right? So.
But if someone doesn't call it, it doesn't matter.
Right. So at the point where you could define it, give it no body, but then if you see code in the main function that's actually calling it, you don't know what to do. What do you do? It has no body. What do you know? What do you return a 0 and let it go? Or should you let it be a compiler saying you need to give a body to this method or something like that? So yeah, we would want this to be a compiler error, and that would be the use. That would be the use of it. So then, why did we put this burden on ourselves? Why did we create this class that has two methods with no bodies, and then have everything inherit from it? Well, we talked about how you can have a method in a base class, and then you get it for free in the derived class, but you have an opportunity to rewrite it if you want. So for design reasons, we might want to force an area and a perimeter function on all of these. But at the shape level, we don't know how to calculate. Shape doesn't know how to calculate the area of a circle or a square or anything like that. You have to be in circle to define it. If we define it here as pi r squared, that's true for circles, but not true for squares. So we don't want to write pi r squared here. That's no good, because then square is going to inherit that, and that's no good. So what we're really doing here is we're saying, I want to make sure every one of these objects has an area function, but I can't define it at the moment. By giving it no body, the compiler will force each of these to define it. And actually will give compiler errors if you don't define it. But just to accentuate that it has no body, that this method is actually not real. It's not something you can touch. It's really an abstract method. They're going to make us write in the word abstract. Abstract. That's the mechanism the compiler knows, oh, I know what this means. Anybody who inherits this method is required to supply a body for it. If you don't supply it, you're going to cause compiler errors. So whenever you declare a method as abstract, you are saying, I'm not going to give a body for it. I want anybody who inherits from me, I want them to be required to supply the body. And we'll do the same for the perimeter function. Now what if, suppose you have a class, and obviously I left some space here because I'm going to write a word in there. Suppose you have a class that has at least one abstract method in it. Could you ever, if you were designing the compiler, would you ever allow someone to create one of these? Would you ever allow someone in the main section of the code to do this? What's this called? Shape? new. Would you ever allow someone to create an object of type shape? If the object itself has a method that it can't even itself define, would you ever allow an object to be made of that type? And if not, what's your argument why you would not? It's kind of like the argument we just made. We don't want there to be an object that has a function with no body because someone may call it, and we don't know what to do. So if there's at least one abstract method in a particular class, you should never be able to create one of those. It's kind of like saying the entire class is abstract. It's there for theoretical reasons, but it's not there to, you're not supposed to make objects from it. You're supposed to inherit from it and make lower level objects from it. Because if somebody was able to create this S object, then they could say S draw, S area. You know, X equals S dot area, and area is not defined. By definition, we have decided to create a function and intentionally not define it. That's what an abstract method is. It's a method that we intentionally are not defining. And then, right, the question is why create it? We want anyone who inherits from us, they have to be required to define it. So this would also cause a compiler error. So now that the entire class, since there's at least one method that is abstract, if there's at least one method that's abstract, it means the entire class is abstract. And if a class is abstract, by definition, if anyone goes to create an object of that type, they're going to hit a compiler error. So the class itself is abstract. And we can mark that by putting in the word abstract here. Now we're declaring this class shape as abstract. Let me change the color. So today purple means abstract. So shape in this example is an abstract class. What does that mean? It means that you can create an object of type shape. We can create objects of type circle. We can create objects of type graphic circle. Any of these we can create objects of. We can create any of those objects, but the ones that are, anything that's abstract, we can't actually create it. And why is it there? Because we want to have everyone who inherits from it to be required to write these methods. Now, if we ever go and create a circle, we're guaranteed the circle has an area function and it has a discrete, pi r squared. It'll have the actual way to calculate. If we don't write how to calculate, if we don't write a body for it, we won't be able to compile a circle. So this is kind of like enforcing a design for every shape that we are going to actually make. We're enforcing that they will all have these functions. Okay. Now there's a downside to doing this. Well, the upside is that we enforce these rules on our objects. The downside is in Java you can't inherit more than once. So for example, if we decided that the definition of a circle, it would be nice if we can inherit from something else, we now can't. We used up the one time we're allowed to inherit. But let's just say, for example, sticking with this circle example, suppose we decided that we wanted all these objects to be drawable. Let's say we wanted to have another class called drawable. and we would like circle to inherit from. So let's say drawable had functions like, let's say we're going to draw something, we would pop up a window with a certain height and a width, and we put a spot in the middle where we want to draw the circle, and then based on the description of the circle, the x and the y and the radius, we would then draw the circle. Suppose we wanted something like that. We want to have a window pop up that can draw these pictures. So we might want to have another class called drawable, which tells us how to draw, which gives us information about how to draw the object. And then we also want shape to be able to supply functions like area and perimeter. It looks like we would like to have circle inherit from two different things. Information on how to draw it and information about a shape. But we don't have multiple inheritance, is not allowed in Java. So we're not allowed to do this. You can't say class circle extends shape, extends drawing. We're not allowed to extend twice. And then we would define the class circle, which is like, what was it again? Double x and y and r. It had an x and a y and an r. We're not allowed to say extends twice. So, and the reason for that is it's a long talk, but in C++ you are allowed to multiply inherit, and there's a lot of problems with doing it. So the creators of Java decided to get rid of multiple inheritance. But they allow you to, you could kind of think of this as faking multiple inheritance. You're allowed to do what would be called implementing an interface. You can kind of think of this as multiple inheritance, but it's not quite. So what we can do is this. We can declare, this is not a class now, this is a, where's this to? This is not a class, but this is what's called an interface, but it looks a lot like a class. Create some methods, and I'll use 3 methods in this example. Okay. This looks a lot like a class, right? Only difference so far is that this word interface appears here where you're used to seeing class. Right? What else looks different? Anything off the top? Anything off the top of your head? It's almost like we're declaring a class. But, does that, okay, well, one thing, maybe you think I left this out. I'm actually leaving this out on purpose. A class has, what basically makes up a class? It's basically a collection of methods and a collection of data, right, to store information, like the X, the Y, and the R. And then you could write methods that, you know, you can change the X, the Y, and the R. You could write a method that says double the radius, so it takes whatever R is and multiplies it by 2. So we could have, a class has a bunch of methods and a bunch of data. An interface is a, we'll think of it as a class, but it's like a class but with less, two major things missing. Number one, there's no data allowed. It's just methods. And when we start to talk about public and private and protected stuff, classes are allowed to change these fields, but in an interface, everything is public. So all really the word interface is coming from is the fact that you can use this, you can use these methods to talk to the object, but it doesn't have any data itself. So an interface declaration is very, very similar to a class declaration, but it's limited. You can only have methods, number one. All of the methods have to have no body at all. So they're kind of like abstract methods. They have no body at all. The body will have to be defined by the class that not inherits this, but implements this. So for example, we can't define how to do set color here in the interface. We have to tell anybody who implements this, kind of like the shape thing. Anybody who inherited shape would be required to rewrite all the abstract methods. These are, by definition, they're all abstract methods automatically, because they'll never have a body, and an interface will never have its own data. All an interface really is a collection of abstract methods. That's all it is. So it's a very limited, it's more, the abstract class was a limited version of a class because all the methods have no bodies, right? This is even more limited than an abstract class. The methods have no bodies and you cannot add any data. We couldn't add an R or we couldn't add a resolution or anything. We're not allowed to add any data. And in addition to that, all the methods must be public. So it's a very, very limited concept. Anybody who tries to, the word is not inherit, the word is implement. Anyone who tries to implement this is required to write the bodies of these methods. Just like when you inherit from an abstract class, you're required to write the bodies. If you implement an interface, you're required to write the bodies for these. Okay. So, what would be the syntax for implementing this? Let me see. Erase this interface. So just remember what it said. We're just going to use those three methods. If we wanted if we wanted our graphic circle to implement, we wanted our graphic circle to implement. Well, no, if we wanted to create a new class where we could draw, and let's use rectangles now, because we've been using circles a lot. We wanted to create a class for drawing a graphical rectangle that would look like this. We'll draw a little rectangle just to not keep using circles in our example. This would extend rectangle and then it would implement implements drawable. So what we're kind of doing here, just underline this header. We're kind of, well, that's more of a picture, but it's kind of like this. We're saying we had a class called rectangle. And we had this interface, I'll use a different color, drawable. And drawable had the functions that we just wrote, you know, about setting the color and setting the position and that kind of thing. This actually has real data in it, like in it, what would a rectangle have? An X and a, I guess it would have an X and a Y, and then a height and a width. And yeah, I guess that's about it. Drawable had those three functions, you know, set the color and draw it. We're now creating a new class. So classes I'll draw in red. We're creating a new class called drawable. Drawable rectangle, which inherits from rectangle, and then it implements the drawable interface. So what does the drawable interface mean? Drawable interface had three kind of like abstract methods, three methods with no bodies. That means we are required, we're writing the class out. We're now required to write the bodies of those. If we don't write the bodies, we're going to get a compiler error. But what this is basically doing is now saying a drawable rectangle is something that is a type rectangle. We're inheriting from rectangle. But we're also guaranteed that the methods that are, the abstract methods that are here will be here. Okay?
If that implements drawable, would that be all on one line?
Right. Yeah, I just ran out of room. So, right. So the extends is a keyword, and now implements is a new keyword in Java. So what we're really saying with this definition is that this new class, drawable rectangle, inherits from rectangle, and we are going to now, we're guaranteeing that the three methods that are in here, we're going to supply a body for them. And if we don't, if anyone tries to create one of these objects, they'll get a compiler error. Okay. So, what we can do is now, since this is a class, we're allowed to add more data. Only interfaces you can't add data. So we could do something like this. We could say color C, double, height and width, and then we could say we could do a constructor. And we could define what that is. We could call it the super. With the super of a drawable rectangle would be the rectangle, and maybe that has a height and a width. And then we could do other stuff. So we could define a constructor for this. But now that we declared that we implement this interface, which had three abstract methods, we now are required to write in the bodies for those. So, just to kind of make the point, I could say void set and I think color we wrote before had a parameter C type color, so we could just say this. Dot C. And then we have to So we're required to write the bodies for all the methods. We get a set position. Which took in double X, Y, and the body for that would be this. X, X, this, Y, and then we have to write the body for draw, as promised. So we're basically, when we implement an interface, we're promising to supply the bodies for those methods. And what goes on in here could get a little complicated, but we're basically giving the instructions on how to draw one of these rectangles. So we just want to make sure we put the code in. So what we've now done is so this is basically a new class. We've seen this before where we extend from some other class. That means we're just inheriting everything it has, right? We take all the data fields, we take all the methods, we get them for free. And now we have this new concept of implementing an interface. This, you could think of it, I don't know if this is adding confusion or making it more clear, but you could think of this as another type of class, but it's a very limited class. So you could kind of think of it like we're multiply inheriting, but we're not really. We are getting, if this was a class, we'd be getting its data and its methods. But it's an interface. So number one, it has no data. Number two, it has methods, but the methods have no bodies. We're not really inheriting much. We're just inheriting the names of the methods. And we're now making a promise, otherwise you won't be able to compile. We're now promising that we are going to supply the bodies. 1, 2, and 3. These are the three methods that are described in this interface. By implementing that interface, we are promising to supply those. Now you might think, why we're just adding a headache to ourselves, right? Why are we promising? Why not take this line out and then we can leave a few of these methods out? Why do we want to force ourselves to have to supply these methods?
You can dictate exactly how a programmer will use your class or your functions.
Okay, that's a good point. Now let's say we decided that all drawable things, right? Like we had squares, circles, triangles, and then we had drawable versions of all of them. Suppose we decided that we want all drawable ones to make sure they have these methods. There's two ways we can do it. One would be to create an abstract class called drawable with these three methods. Set color, set position, and draw. And then force everyone to inherit from it. And if it's an abstract class, we can actually even have more freedom. We can add data. Abstract classes can have data, but interfaces cannot. So if abstract classes can do everything an interface can do, why give the programmer a choice? Why not just have abstract classes? So everything an interface can do can be done with an abstract class. Right? Because think about it. What's an abstract class? An abstract class is a class where some of the methods, maybe not all of them, some of them have no body. Some may have a body, some may not, but at least one does not have a body. And you're allowed to have data. An interface it's like a class, but it has no data, and all of the methods have no body. So it's even more restrictive than an abstract class. So why even have this concept if you already have abstract classes? And the answer ends up being you're only allowed to inherit once. So if you use if we use drawable as the class, then we can't use shape. So we made an abstract class in this example called shape that we inherited from. Now we can't inherit again. But it turns out that the drawable concept, like you were saying, it's so that they all have the same behavior. It doesn't need any extra data, and it just is a list of abstract methods. So we're guaranteeing that these three methods, the bodies of them will be filled in by the class that implemented it. If you implement an interface, you are guaranteeing that you're going to write the bodies for all the methods in that interface. Now what we can do is we can create objects and use a reference of type drawable and point it at a drawable circle or a drawable rectangle. Let me write an example like that. We can go like this. Now that these exist, so it's kind of like we had shape, which had rectangle, which had drawable rectangles. So drawable rectangle inherited from rectangle, but it also, this is a strange way of drawing it, but it also implemented drawable. Drawable was an interface, a collection of methods with no bodies. We decided to implement it. We decided to let drawable rectangle implement drawable, which means we promised to write the bodies of these methods in this class. And what did that do for us? Sounds like we just made a big headache for ourselves, but now we have the freedom to do this. We can create an array of shapes. We can create an array of drawables. Drawable. So what, you remember this was an array, right? An array of type drawable. We're calling it drawables with an S. And then we're making a new array, getting a piece of storage of that type. We could then say, we can create, what we're now doing is this. I'm making drawable circle an object of type drawable circle. Creating a new one of type drawable circle and giving an x and a y of 1. I need a radius too. Okay. We're creating a drawable circle out. We could create a drawable square. And we can create a drawable rectangle. dr equals new drawable okay. So we can create three different objects of the original types. These are objects of the original type we talked about. We can now do this. We can say shape 0 equals DC. Semicolon. Write this out so take up less point space. Okay, so here's where there's a little something starts to get interesting. We created three objects, a drawable circle, a drawable square, and a drawable rectangle, by declaring them directly as the types that they are. We now have an array of shapes. Okay. What we've now done is taken these three objects and had their references equal to the shapes references. So you can now take, here's where something looks a little magical. You can take a shape reference and have a drawable circle, have it referred to a drawable circle. You might think this is a type mismatch and you might get a compiler error. Kind of like when you say a float equals an integer, you know, it says, oh, I can't figure out what you're doing, or I don't want to lose anything. This is actually allowed. This is called, well, yeah, so this is actually allowed. And we could also make an array of type drawable. Now, drawable, these are just references. They're references to drawable things. Drawables are anything, any object that implements the drawable interface. Any object that is a reference to a drawable can refer to any object that implements that interface. And so what we can now do is we can go through an array like this. We could say for int I equals 0, I less than what we're really doing here is going through the array of the objects that we wrote, that we created, and we're going through the shapes array and calling the array function and having it total up to equal to total array. We're telling you that, in total area equals 0. So we have some total area of 0. Then we go through all the shapes we have. We call the area function for the circle, the square, all of them, and just have it all total up. And then we go through the drawable array, which is really the array of the same items, and we start drawing them. So what we were able to do, using the abstract class and the interface, we can create arrays of objects. We can create arrays of objects of type shapes, which we know have the area function, because shape had an abstract method called area, which means we were forced to write that method. So we're guaranteed that all shapes, and shapes don't have to be a circle or a square, as long as it's just anything that inherits from shape, we're guaranteed to have an area function. And then we can make an array of drawables, which is the same objects, and we can go through those arrays and we can set a position and then draw the object, and we could just draw all our objects. And, so they don't draw all on top of each other. We multiply I by some scale, so they all just kind of move over. Any question?
Wouldn't shapes bracket I, the shapes array area, wouldn't that be a double? And therefore by putting...
Oh, did we say this was a double function?
Yeah, we didn't typecast it there, and
Okay.
it was a double.
Yeah, so this should be double. Okay, that's a good catch.
I didn't know if you wanted to do that or typecast it down or what. So.
Okay. Yeah, just to make sure they line up. Yeah, we would have got a compiler error with that. Okay.